Hi, welcome back. We're working on section 8.4, trigonometry. Well, it has begun. First off, let's figure out what this word trigonometry means. It's a two-part word. It comes from ancient Greece. I guess a three-part word. Tri meaning three, gon meaning side, and metry meaning the measure of. So trigonometry is basically the measure of three-sided objects, the measure of triangles. And as you can see by our objective, we will be calculating side and angle measures of right triangles using trigonometric ratios. Keep an eye on that essential question, how I can remember them, because we've got a lot to get through. Let's start off with our trigonometric ratios. We have sine, cosine, and tangent. They are abbreviated as three letters. SIN is not sin in this class. It is sine. Sine, cosine, tangent. Now, the easiest way that I have found to remember these is to think about them in terms of a little shortcut called SOHCAHTOA. So, SOH, ka, CAH, TOA, TOA. And what these letters stand for are the sides of the triangles that create the trigonometric ratios. The sine of an angle is always the opposite over the hypotenuse, the side opposite that angle divided by the hypotenuse of the right triangle. So if I'm looking at this angle A, then the side opposite A is this side and the hypotenuse is this side. And so the sine of A would be this measurement divided by this measurement. The cosine is A over H, A standing for adjacent. That is the side that's closest to the angle, but not the hypotenuse, divided by the measure of the hypotenuse. And the tangent is the opposite over the adjacent. So the side opposite the angle we're looking at divided by the side adjacent to the angle, but not the hypotenuse. All right, let's find the ratio of each one of these angles. All right, we've been asked to find the sine of angle P. Here's angle P, and so I need to look for the side opposite angle P, which is this one, and the hypotenuse of the right triangle, which is this one. And so I can write that as a fraction, opposite over hypotenuse. Opposite the letter P is, angle P is 15, and the hypotenuse of this triangle is 17. And so as a fraction, that is the sine of P. As a decimal rounded to the nearest hundredth, we need to use our scientific calculators. I have a TI-30 with me today, and I'm going to look for the button that says sine. For me on this calculator, it's located right here next to the pi button. It's literally going to be SIN, sine. So I'm going to push sine, and then I'm going to, oh, wait, this function only works if I'm using an angle measure. I'm just going to type in this fraction and write the decimal expansion. So 15 divided by 17 is about 0.88. All right, let's do cosine. We want the cosine of P. Again, here's angle P. And cosine is adjacent over hypotenuse. All right, so I need the fraction that is the side adjacent to angle P divided by the hypotenuse of my right triangle. The side adjacent to angle P measures 8. The hypotenuse of this triangle measures 17. And so the fraction of the trigonometric ratio cosine P is 8 divided by 17. I'm going to put 8 divided by 17 in my calculator for the decimal expansion, and I get 0.47. Let's do the last one together. Let's do P, and I'll leave you these three to figure out on your own. We want the tangent of angle P. Here's my angle P. Tangent is always opposite over adjacent. So the side opposite angle P divided by the side adjacent to angle P. Remember, adjacent is the one that's helping create the angle that we're interested in, but is not the hypotenuse of the triangle. All right, opposite angle P is 15. Adjacent to angle P is 8. And 15 divided by 8 is 1.875. Which I'm going to round to 1.88. And since I'm rounding, I'm going to put squigglies. All right, so now that we've got these trigonometric ratios, we'll leave you to some practice on your own. This is all well and good and will let us find information like the measure of side lengths. Oh, I don't have, I'm sorry, I'm just looking through here. I don't have that as a measurement. So let me make up an example real quick. Sorry, let's do this guided practice together so that you can see how we can use this to solve for a side measure if we don't have it. Okay, let's pretend for a second that we do not have this measurement here on the hypotenuse of my triangle. And let's suppose I don't have this side measurement either. So I'm missing all of that information. But I do have the measurement of this angle right in here. Let's pretend the measure of that angle is 18 degrees. I'm just making stuff up. I don't really know what the measure is, but let's pretend it's 18 degrees. And we want to find both the hypotenuse and the side opposite the angle. All right, let's look at our trigonometric functions, our trigonometric ratios, because those are going to help us out. And again, I'm going to put my little mnemonic device, my little reminder of SOHCAHTOA. That's sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. Okay, now that we have this, I'm going to look at what information I do have and what information I'm interested in. I do have an angle, one of the acute angles. I have this one. And I definitely have the side adjacent to it. All right, I have the side adjacent to it, and I'm interested in information on the side opposite, and I'm interested in the hypotenuse. As I look at my SOHCAHTOA and as I look at my trigonometric ratios, I'm going to see which ones are the most helpful. And I'm going to go ahead and color code all the different pieces of here so that it's easy for you to see. So there's my hypotenuses. I don't think that's the right way to plural that. There's my opposites, and here are my adjacents. All right, as I look at angle J, I'm going to go ahead and try to set up the sine of this thing. So the sine of 18 degrees, and it's written this way, equals the side opposite that divided by the hypotenuse of my right triangle. And if I look at this equation, I notice I cannot solve it for one of the variables. I can't solve it for X and I can't solve it for Y. I mean, I could, but there's still a variable in there. And so I don't know what that measurement is going to be. So while this isn't wrong, this isn't helpful at the moment. So I'm just going to throw it away. And I'm going to see about setting up the cosine. So I'm going to set up the cosine of angle J, which is 18 degrees, equals the side adjacent to angle J divided by the hypotenuse of the right triangle. And this is an equation I can solve for x. Now notice that the letters C, O, and S are not variables by themselves. They are the word cosine. And this is like, it's a function, it's a box that the 18 is being shoved into that then creates this fraction out at the end. And I can use this to help me solve for this value of x. As I'm looking at this fraction, I notice the x is in the denominator and I want to get it out of the denominator. To undo division, which is what's happening here, I need to multiply. Because I'm dividing by x, I want to multiply by x in order to get the x out of the denominator. What I do to one side, I have to do to the other. That leaves me on the left-hand side with x times the cosine of 18 equals 12. Now, if you notice, I wrote the multiplication symbol in here. You can write it either with that multiplication with that dot, you can write it with parentheses around the cosine of 18, or you could just write it without and just write x cosine 18. They all mean the same thing. Now, I want x by itself. X is currently being multiplied by the cosine of 18. How do you undo multiplication? You use division. So I'm going to divide both sides by the cosine of 18. And yes, this is starting to look really weird in algebra standards, but the cosine of 18 is just a number. As we saw up here in the previous example, when I took the cosine of an angle, it gave me a ratio. It gave me a fraction, which just turns into decimal. This is just a number. And so I'm allowed to divide by it without any issues. Dividing by it, this cosine 18 is going to cancel with this cosine 18 because I'm dividing by the same value. The left-hand side is x. The right-hand side is 12 divided by whatever the cosine of 18 is. Now, at this point, you're probably wondering, but I don't know what the cosine of 18 is. How do I get a value? Back in my dad's day, back in your grandparents' days, they had a book with huge tables of nothing but these ratios, these decimals out to like 6, 7 decimal places. Nowadays, most scientific calculators, and indeed even the sine cosine function stuff on your telephones, has those already programmed into them. So I'm going to show you how to do it on your calculator, and then in a moment I'll show you how to do it on a telephone. So what we're going to do on our calculator, and again I have the little TI classroom set, TI 30s. I'm going to type 12 and then the divided by symbol, and then I'm going to open some parentheses to tell the calculator that I want everything that I'm about to type in to be done in the denominator of the fraction. I'm going to find my cosine button. It's the button that says COS. I'm going to type it. It's going to automatically open parentheses for me. I'm going to type 18. And then I'm going to close those parentheses. That's the parentheses around the 18. And then I'm going to close them again to close the denominator. And that looks something like, I don't know if my screen is really too small for you to see, something like that. I'm going to check my calculator to make sure it's in degree mode. So you're going to look for either it to say nothing or for it on the screen somewhere to say DEG. If it says rad, like that's so totally rad, it's in the wrong mode. And while your calculation is correct and you typed everything correctly, you're going to get a different value. We'll talk more about why that is a little later in the year. But for now, just make sure it's in degree mode. I'm going to hit enter, and my calculator spits out a value of 12.6175, but I'm going to round it to 12.62. let's show you how to do it on a calculator. So I'm going to open my calculator. You got to see my child stuffed animals. Let me get rid of all of my Facebook notifications. Wow, this is a really telling moment here. All right, going to my calculator, and I have a little button. I'm using an Android. I have a tiny little option that allows my screen to rotate. And when my screen rotates sideways, you'll find the sine, cosine, tangent, a couple other ones, the ln, the log, all of that. I'm going to type in literally this same fraction that I have here. So I'm going to type in 12 times cosine, and it opened up the parentheses there for me. I'm sorry that it's a little on the blurry side in my webcam and kind of small for you. I'm going to type 18 and then hit enter, and it spits out the same value that I calculated before, the 12.617 something that I rounded to 62. Okay, so that's how you would calculate one of the missing side links. Now I want y. You remember this original equation up here that I had that I said I couldn't do anything with because I didn't know the value of y and I didn't know the value of x? Well, now I have a value for x. So now if I want to, I can use this equation and shove this value of x that I just calculated in there and use it to calculate the value of y. And that's what I'm going to do right now. So I'm going to take this equation that I have here and I'm going to write it down here because now I'm ready to use it. Now you might have a question of, could I use tangent? I noticed, Miss, that you did not use tangent. Yes, you totally could use tangent if you wanted, tangent being opposite over adjacent. Just make sure you put things in the right spot and all the calculation, the processes remain the same. All right, I have a value for x now, so I'm going to go ahead and substitute in the value that I have for x. Do not yet have a value for y, so that's staying as a y. My value for x is 12.62. I need to get rid of this divide by 12.62, and I'm going to do that by multiplying both sides by 12.62. Get to hear my mouse clicking away as I write. There we go. Now these 12.62s on the right hand side are going to cancel, and that's going to leave me with y equals 12.62 times the sine of 18. And so in your calculating device, whatever you decide to use, your phone or the classroom little TI-30s, whatever your preference is, we're going to type in literally this. So 12.62 times the sine of 18. Again, making sure I'm in degree mode, and it spits out that y is 3.90. That's rounded to the nearest hundredth, the second decimal place. Now when you're, and let me write out what I had to a couple decimal places. So my calculator showed 3.899794. There's a couple more, but well, that's good enough. Now when I'm looking at these numbers here and I'm trying to round to this decimal place, oh, why did there go? I'm trying to round to this decimal place right here. That did not work. Let me try this again. Oh my goodness. Hello, get rid of the highlight. Let me just write that all over again. 8999794 something. When I'm trying to round to this decimal place right here, when I look one to the right and I see that it rolls over and this one that I'm needing to round is a 9, I have to put the 0 there. And so writing this 0 right here in the 100th place tells everyone that you got to the 3.9 by rounding. You didn't hit it right on the nose. Okay. All right. So now we know how to use trig to calculate the measures of the sides of a triangle. Let's do the inverse, and let's use trigonometry to calculate the angle measures in a triangle. And all of this is using something called the inverse of the trigonometric ratios. This is the symbol for that inverse. It's the sine function, little word, and then what looks like an exponent with a -1. It's not really an exponent. It means inverse. I'm sorry that we don't have enough notation to give it its own thing. This can be read either as inverse sine or as arc sine. Your calculator on your phone will write it a sine, like arc sine. They'll do that across all three of these: arc, cosine, arc, tangent. Your classroom calculators, I think, will just keep it as inverse sine, that is sine to the -1, inverse cosine, cosine to the -1, tangent, inverse tangent, tangent to the -1. And you can reverse these, so you could say sine inverse or inverse sine. I'm sorry that this has like a bazillion different ways to say the same thing. You'll hear me bounce back and forth between all of them. All right, so the example 4 asks us to use the calculator to find the measure of angle A to the nearest tenth, so 1 decimal place. Here's angle A, and now I need to decide what information I've actually been given. I've been given the hypotenuse, and I've been given the side opposite angle A. Looking back at my little SOHCAHTOA thing, I need to figure out which of my trigonometric ratios I have the information for. Usually only one will present itself. If more than one presents itself, you can choose whichever one you want. I have the hypotenuse. That means that the tangent is out because tangent does not use hypotenuse. I've also been given the side opposite the angle, and sine is the only ratio left that uses the opposite and the hypotenuse. So I'm going to write down that the sine of angle A, and I'm going to replace that angle A with theta. You remember our little variable for the symbol of angle measures was theta. So sine theta, that is the sine of angle A, is equal to 18 divided by 27. I am interested in finding the value of theta. In order to find the value of theta, I have to remove the sine function off of the theta. I have to apply its inverse. This is how it's going to get written. I'm going to take the inverse sine of the sine of theta. And what I do to one side, I have to do to the other. So on the right-hand side, I have to apply the inverse sine to the fraction 18 over 27. Now I'm just writing it down. I don't need to try to calculate any of this in my head because my calculator can do all of that hard stuff for me. I just have to figure out what buttons to push in the calculator. And that's why we're writing all this stuff down. The inverse sine function right next to the sine function will cancel each other out and leave me with just the variable theta to represent the measure of the angle that I was interested in. And now I'm going to go into my calculator and I'm going to type in all of this. Sine inverse of 18 over 27. On this calculator, the sine inverse, that is sine with the -1, is right above my sine button. And on the TI-30, it's in light blue, which means I need to push the second button that's blue in order to get it to say sine inverse. And then I type the fraction in the parentheses, hit enter, and it spits out a number, which I'm going to round to the nearest tenth and call it degrees. If I'm doing this on my phone's calculator, and let me grab that real quick, my phone's calculator. Again, I have to spin it around. In order to get the Second, there's a little button, at least on the Android, that's like an arrow back and forth. If I push the arrow back and forth, it's going to change all of the sine, cosine, tangent into sine inverse, cosine inverse, tangent inverse. And so I'm going to type inverse sine and then the fraction. I'm going to put this really close to my webcam, and I'm sorry that it's super blurry. Hopefully you can see it. At least on the Android for me, it doesn't type out sine inverse, like sine with the -1. It types a sine, which is the calculator saying arc sine, which is the same as inverse sine, which is the same as sine inverse. 3 ways to say the same thing. Sorry that that's confusing. My phone is in degrees mode and it gave me the same degree. And so this is the measure of angle A when the side opposite that angle is 18 units and the hypotenuse of the triangle is 27 units. We've got some more guided practice for you to play with. And I've given you some of the answers, partial answer on the second one for you so that you can confirm. If you're taking this class live with me, you'll find my teacher sample, which has all of these worked out for you. Thank you very much for joining me today. If you've got questions on anything I did, please feel free to hit me up in the comments below. Hit a like if you learned something new. Hit a like if you just remembered something that we had done. To my former students who are still watching my channel, thank you for staying subscribed. I really appreciate it. If this is helping you in your college class, leave me a comment below. Let my current students know, those who are getting subscribed, know that this stuff is still helping you even today. Thanks again. Have a wonderful day, and we'll see you in class next time. Bye.